Good evening, children.
Good evening, ma'am.
Good evening. Good evening, children. Yeah. So I think we finished this in the last class, right? Did we finish this graph? We also understood the algebraic way, the algebraic method of finding the coordinates of the points where the graph line cuts the x and y axis. Without making the graph, algebraically giving values for x and y, taking x as 0 and y as 0, you can find the coordinates of the points where the graph line cuts the x-axis and y-axis. We saw that in the last class. So when you take the value of y as 0, because we know that on the x-axis y is always 0. On the x-axis, y is always 0. Like for example, now this point is given by the address -4, 0. This point is given by the address 2, 0. So on the x-axis, y is always 0. On the x-axis, now this point on the x-axis is 9, 0. So when we take y as 0, you will be able to find the coordinates of the point where the graph line cuts the x-axis. When you take y as 0, because where is y 0? On the x-axis. So when you take y as 0, so 2x minus 3y minus 12 is equal to 0. So 2x minus 3 into 0 minus 12 is equal to 0. So we get 2x. This is 3 into 0, which is 0. So 3x is equal to 12. X is equal to 12 by 2. X is equal to 6. So when y is 0, the value of x is 6. So the ordered pair is 6, 0. The ordered pair is 6, 0. The x coordinate first and then the y coordinate. The x value is 6, the y value is 0. So 6, 0. Now what is this 6, 0? 6, 0 is the point where the graph line cuts the x-axis. See here, you can see it graphically also. See, this is the algebraic way of working. That is without making the graph. Without making the graph, algebraically working like this, you can find this point. You can find the coordinates of this point where the graph line cuts the x-axis. For that, you'll have to take y as 0. And when we take x as 0, because we know that on the y-axis, x is always 0. On the y-axis, x is 0. Now, for example, the coordinates of this point is 0, 3. X coordinate is 0, y coordinate is 3. So on the y-axis, x is always 0. That is the x coordinate. X coordinate is always 0 on the y-axis. So when you take x as 0 and find the corresponding value of y, so 2x minus 3y minus 12 is equal to 0. When x is 0, 2 into 0 minus 3y minus 12 is equal to 0. So 2 into 0 is 0. So we get minus 3y is equal to 12 on transposing. Minus 3y is equal to 12. So y is equal to 12 by minus 3. Y is equal to minus 4. And the ordered pair is the value of x is 0 and y is minus 4. So that's why it's called an ordered pair. Ordered pair because the order is important. The x value first and then the y value. X is 0, y is minus 4. And this is the point where the graph line cuts the y-axis. When you take x as 0, you can find where the graph line cuts the y-axis. When you take y as 0, you can find the point where the graph line cuts the x-axis. So this is the algebraic way of working. That is without using the graph, without making the graph. So making the graph and answering this time, making the graph and answering this question is time consuming. It's time consuming. But if you're asked to make the graph, you have to make the graph. But if the question is simply find where the graph line will cut the x and y axis, that is, the question does not expect you to make the graph. There is no meaning. There's nothing like draw the graph of the equation. The equation is given and say you're asked to find the points where the graph line would cut the x and y axis. So if you don't find those words, draw the graph, you need not make the graph. You should make the graph only if it is mentioned, draw the graph or make the graph. Otherwise, you don't have to make the graph. Like this, algebraically, you can work and quickly find these points. So I had asked you to take down this in the last class. I hope all of you have it in your book.
Yes, ma'am.
Okay.
Yes.
All right. So this is from the graph. So because here we are asked to make the graph, draw the graph of the equation. So we have to make the table. See what kind of equation is this? It is a linear equation in two variables x and y. It's a linear equation. Why is it linear? Because the power of x is 1 and the power of y is also 1. So it's a linear equation in two variables x and y. So we know that a linear equation in two variables x and y is represented by a straight line in the Cartesian plane, and see the straight line here. So for that, you'll have to take the equation. And here, because the coefficient of x is 2, we have written x in terms of y. So that we'll get x is equal to something by 2. It's 2x, right? So when you work for x, you'll get x is equal to something by 2. This 2 will come for division. So write x in terms of y. Write x. This is writing x in terms of y. Then you'll have to give different three values, at least three values. You'll have to give three values for y and find the corresponding values of x. You'll have to give three values for y and find the corresponding value of x. So we take x is y is 0, y minus 2, y2. And we find the corresponding values of x. And here we have the table showing the x and y values. So plot and obtain the straight line. So you can see here, there's a scale and the equation written on the line. And the 3 points which we have plotted, you can see their address here. And what is the question? Where does the graph intersect the x and y axis? So the graph intersects the x axis at the point. See, this is the graph line. Where does it cut the x axis? At this point, 6, 0. And the line, the graph line cuts the y axis at 0, -4. You will have to write that. They've asked you to mention that. Where does it intersect? The question is asked, so you'll have to answer it. It's not that I made the graph and it is clear from the graph that they meet here and here. No, no, because they've asked that question, where does it meet? So you'll have to write the graph intersects the x-axis at this point and the y-axis at this point. And I also mentioned that some of you, like say you plot the 3 points and you get like this, you just cannot join these three points like this and leave the line like this. And then you will say that my graph line cuts only the x-axis. It does not cut the y-axis. You will say that the graph line cuts only the x-axis. It is not cutting the y-axis. No, it's a line. You'll have to produce it. You'll have to produce it like this. You have to produce it. It's a line. So now you can see it does cut the y-axis at this point. So it's like that. Yes. So use the equation. I'd asked you to complete this. Let's understand this one now. Use the equation 3x plus 4y is equal to 7 to write x in terms of y. To write x in terms of y. Okay. So 3x plus 4y is equal to 7. You need to write x in terms of y. So how do we write that? 3x is equal to 7 minus 4y. X is equal to 7 minus 4y divided by 3. So we have written x in terms of y. It's also called make x the subject of the formula. Make x the subject of the formula. The subject of the formula. So this phrase is normally not used in CBSE, but in ICSE, this is how it is mentioned. Make x the subject of the formula. So when you have to make x the subject of the formula, this is how we express. Now, for example, you have this formula, volume is equal to LBH. Now, if the question is make H the subject of the formula, make H the subject of the formula, you need to write a H is equal to volume divided by L into B. So we have made H the subject of the formula. Volume of a cuboid is length into breadth into height. Make height the subject of the formula. So then you'll have to express like this, H is equal to V divided by L into B. Similarly, here we write X in terms of Y. That means we make X the subject of the formula. So you need to write it like this, X is equal to something. All right. Now draw the graph of the equation. So what should you do? You must take different values for, you should make the table. You should make the table. You must take different values for Y and find the corresponding values of X. So you can see here. And when you take the values, you need to be very careful. You see to that when you take a particular value for Y and when you work that, you must get a value for X, which is an integer, because that is more convenient to plot. Meaning it can be negative, positive, or 0. If you get an integer, it's easy to plot. Integer. 0, 1, 2, 3, 4, 5, 6, integer. So any number like this. Whatever you see on the number line. 0, 1, 2, like this. It's easy. If it's an integer, it's easy to plot. So we'll give values for Y such that we'll give some integer values for Y so that we get an integer value for X. We'll give some integer values for Y so that we get an integer value for X. So actually, I did not just put Y is equal to 1. I first worked it. Like I'll do it in my mind. What will happen when I take Y as 1? So I work it in my mind. 4 into 1 is 4. So 7 minus 4 is 3. 3 by 3, 1. Oh, okay, then let me take Y as 1. It's like that. It's not randomly taking some value. It's not randomly, I just start off with let Y be 1. No, it's not like that. You work it and then meaning you do it in your mind. You work it in your mind and then you write it in your book or paper. It's like that. So we just work it in our mind, So what happens when Y is 1? When Y is 1, you just work it. 4 into 1 is 4. 7 minus 4 is 3. And 3 by 3 is 1. Good. So X is equal to 1. When Y is 1, X is also 1. So we'll go ahead with that value of Y. So when Y is 1, X is equal to 1. Then we take another value. Now I'll tell you something here. Please listen. Maybe you've completed this, but I did not explain this in the last class. I just made you complete it. I don't know how many of you, raise your hands, how many of you finished this one? Be good. Just don't raise your hand if you have not finished it. Really? Krishmika, Shri, Prajit, Danya. Danya, yes, you shared your work with me. Good. Netra, Krishmi, Sindhu, Sanjay. Okay. All right. So Tanishka, Madhumita, Arjun have not done. Fine. So maybe we'll understand now, children. And since you've already taken the screenshot, you can complete it later. We'll just understand how it goes now. So like that. Now, when you listen to this part very carefully. Now, Y is equal to 1. When you take Y as 1, you get a convenient value for X. Correct? You understand where I say convenient? When you take Y as 1, you get a convenient value for X. So the coordinates are 1, 1. It's easy to plot 1, 1. Now, what is the next value of Y you should take? That's the question. Now, the value you have taken now is 1. Skip by 3. Skip count in 3 because the denominator is 3. Because the denominator is 3, you skip count in 3. That means after 1, don't take 2, don't take 3, take 4. After 1, don't take 2 and 3, take 4. That is like 1 plus 3. Take 1 plus 3, 4 is the next value. If the denominator is 7, if supposing the denominator is 7, then, and supposing when Y is 1, X is also 1, next value, you take 1 plus 7, 8. You skip count in 7. The denominator is 3. The denominator is 3. Now, when you divide any number by 3, will not give an integer. Any number by 3 will not give an integer. So you want to take, some specific values of y where you will get an integer value for x so that it's easy to plot. So what is the next one? So you tried, trial and error, you tried and you figured out that when y is 1, x is 1. So we are happy. We got one value. That is enough. If you figure out one value like this, that's enough. Other values you can easily get. How? See, I'm repeating. This value y is equal to 1, we figured that you have to figure out. What works, you should first figure out. So when y is 1, when that is y is an integer here. Y is 1 is an integer. X is also 1, integer. So this is easy to plot 1, 1. Now you identified one value for y. It's easy to get the others. Now the next value of y can be 1 plus 4 or okay, I'll come to or later. 1 plus 4. What is not 4? Sorry, not 4. Sorry, 1 plus 3, the denominator. Not 4, whatever is the denominator. So 1 plus 3. Or the other value can be 1 minus 3. Meaning you keep subtracting. Now you take 1, keep adding 3 to get the next values, or you subtract 3 and get the other values. Do anything. All that will give you an integer value for x. Now, so this is 1. The denominator is 3. So 1 plus 3 is 4. So let's take y as 4. Let's take y as 4. After 1, y is 1. We're taking y as 4 because the denominator is 3. 1 plus 3 is 4. So y is 4. Now, when y is 4, what's the value of x? What's the value of x? So y is 4. 4 4 is 16. 7 minus 16 is, what is 7 minus 16? Minus 9. Minus 9 by 3. Minus 9 by 3, which is minus 3. Seven minus 16 by 3, minus 9 by 3, which is minus 3. Then the other value, we got y is 1, right? You can also take the other value as 4 plus 3, 7. 4, see, we got y as 4 here. 4 plus 3, you keep adding 3. You can take 7 also. You can take 7. I have taken this value minus 3. This value minus 3. Minus 2. Minus 2. When y is minus 2. When y is minus 2. So when the value of y is minus 2. 4 into minus 4 into minus 2. 8. Plus 8. 7 plus 8, 15. 15 by 3, 5. 5. Figure out the first value of y. We have to substitute for y and find the corresponding value of x. We'll have to give some value for y and find the corresponding value of x. Figure out the first value of y. After that, you can get any number of values for y and still get integer values for x. Any number you can get. Figuring out the first number is important. After getting this one, the next value of y will be whatever is the denominator here. 1 plus 3, 4. Y is 4. The next value can be 4 plus 3, 7. 7 plus 3, 10. 10 plus 3, 13. 13 plus 3, 16, and so on. Or it can be, after finding the first value 1, 1 minus 3, minus 2. Minus 2, minus 3. Keep subtracting 3, minus 5. Minus 5, minus 3, minus 8. Like that you can take values. Okay. I hope all of you understood. Try that. So like this, we make a table, XY table, and we get the values for X and Y. We work and we get the values for X and Y. Now the other one. The question actually here is, use this equation. Are you all listening to me, class? Following, all of you?
Yes, ma'am.
Yes, ma'am.
Very good. Very good. Thank you. So what is it here? Use the equation. This is the first equation to write x in terms of y. Okay, so we have written x in terms of, what is this? To write x in terms of y, meaning this one, writing x in terms of y. What is the next thing? Draw the graph of the equation. So you must work all this, get this table and plot this and get the graph. So you plot 1, 1, minus 3, 4 and 5, minus 2. Okay. So where is it? Where is it? 1, 1, 1, 1. This is 1, 1 here. 1, 1. Then minus 3, 4. minus 3 is here, comma 4 here, minus 3, comma 4. And then 5, comma minus 2. 5 is here, minus 2 down here, minus 2, 5, comma minus 2. So when you join these 3 points, you get this line. And you can see I've written the equation there. The equation 3x plus 4y is equal to 7. That equation, which is given, 3x plus 4y is equal to 7. Write that equation. And every point, which is plotted, you can see the address near the point. That's important. Of course, scale. And of course, scale. So we got the first line. Now read ahead. Now use the equation 3x minus 2y is equal to 1. So you see that here. Use this equation to write y in terms of x. So here they want you to write y in terms of x. So what have we done so far? So far we have taken the first equation, and according to the instruction in the question, we wrote x in terms of y. We wrote x in terms of y. We finished this one. We drew the graph. Yeah, we plotted these points. We made the xy table, and we assumed 3 values for y and found the corresponding values of x. And hence we constructed this xy table, plotted the points, and we got the first straight line. Now read the question ahead. Now use the equation, this one, to write y in terms of x. So you can see it here, y in terms of x. So 3x minus 2y is equal to 1. Minus 2y is equal to 1 minus 3x. So y is equal to 1 minus 3x by minus 2. Now, if you want to take away that minus sign from the denominator, change the signs in both the numerator. It's like this. This minus goes up to the numerator, right? So it will become y is equal to minus 1 minus 3x by 2. See that minus sign in the denominator, you can take it up to the numerator like this. This minus sign. So y is equal to minus of 1 minus 3x by 2. So what will happen? It will be minus 1 plus 3x. That's what you see here, 3x minus 1. Minus 1, see here, minus 1. Minus into minus plus 3x, see here, plus 3x by 2, by 2. When you take this minus sign to the numerator, it will be y is equal to minus 1 minus 3x by 2. Now it becomes minus 1, minus 1. Minus into minus plus 3x, so plus 3x here. In other words, 3x minus 1 by 2. Now here you'll have to give different values for x and find the corresponding values of y. You need to give different values of x and find the corresponding values of y. So x is 1. when you take x as 1, see when you take x as 1, 3 into 1, 3, minus 1, 2, 2 by 2, 1, y is 1. Y is 1. So like we did here, you can apply the same concept here. X is 1, no? So for the next value of x, what is the denominator 2? Add 2. Add 2. 1 plus 2, 3. Same thing you can apply here. But normally, see, with 2, you will either get something like 2, 3, 4, 5, 6, or you will get 2.5, 3.5, 4.5. So for 2, when the denominator is 2, you don't have to bother about what value to take, because if whatever it is, you will be able to plot. Because when you divide by 2, so like if it's 10 by 2, you will get 5, or if it's 11 by 2, you will get 5.5. It's still easy to plot that. If it's 12 by 2, 6. If it's 13 by 2, 6.5. So with 2 denominator, we shouldn't have any problem. Still, to apply, you can use this one as a universal idea, meaning it's not that it's only for 3. For all the values in the denominator, you can use it. So now here the denominator is 2. We have found the first value, x is 1. So the next value, 1 plus 2, 3. See, I've taken here, x is 3. And 1 minus 2, minus 1, you can see here, I've taken minus 1 here. So I add 2 and subtract 2. See, the denominator is 2. I figure out the first value. When you take x as 1, y is also 1. So I got the first value of x. Now, x is 1, right? Add 2. Or x is 1, subtract 2, because the denominator is 2. 1 plus 2, 3. So you can take x as 3. 1 minus 2 is minus 1. You can take x as minus 1. 3 values are enough. Like that. So you have to give the values for x, substitute in the formula, and find the corresponding values of y. and write the x and y values in this xy table. Now plot these 1, 1, 1, 1, 1, 1 here. Here also we have 1, 1. Here also we have 1, 1. So it's the same point. -1, -2. -1, -2 here. And 3, 3, 4. 3, 4 here. So again, join. You can see the straight line. I've written the equation on it. See here, 3x minus 2y is equal to 1. And whatever points we plotted, you can see their address here. 1, 1, you write only once. That's enough. You don't have to write it 2 times. So we got now both the lines we got. Okay, next what? Draw its graph on the same graph paper used above, meaning okay, fine, used. Let me take out this word. So draw its graph on the same graph paper. Okay, all right. So we have drawn the graph on the same graph paper. Now shade the region bounded by these two lines with the line x is equal to 0. Now who is this x is equal to 0? Now when it is with the line x is equal to 0, this we need to understand carefully. See what is given with the line x is equal to 0. Okay, now x is equal to 0. X is equal to 0 is a linear equation in one variable x. So how is it represented? It's represented by a point on the number line. 0, 1, 2, 3, 4, -1, -2, and this is 0. So x is equal to 0 is here. Now, this is when we treat x is equal to 0 as a linear equation in one variable x. But when you treat x is equal to 0 as a linear equation, in two variables x and y, it will be x plus 0y, 0 into y is equal to 0. X plus 0y is equal to 0. Now we know that when you treat this equation as a linear equation in two variables x and y, it is a straight line. It is represented by a straight line in the Cartesian plane. Now, when you look at x is equal to 0, there is only one variable x. Clearly, it is a linear equation in one variable x. And what is the geometric representation of a linear equation in one variable x? It is represented by a point on the number line. And here is what? X is equal to 0. Now, when you regard the same equation, x is equal to 0, as an equation in two variables x and y, then how will it look like? X plus 0y is equal to 0. The y variable is missing. So write 0y. X plus 0y is equal to 0. Now, when you treat x is equal to 0 as a linear equation on two variables x and y, it is not, the geometrical representation is not a point on the number line. Instead, it's a straight line in the Cartesian plane. And to get the straight line, we have to make the xy table. To get the straight line, you'll have to make the xy table. And how do we make the xy table? X is equal to 0. That means x is always 0 for any value of y. That's what it is. X is equal to 0. See here, x is equal to 0. X is equal to 0 means x is always 0 for any value of y. We have done, similar situations earlier, like when we had x is equal to 4. X is always 4 for any value of y. So similarly here, x is always 0 for any value of y. You give any value of y. All right. Just make a note of this, children. You can just put a cloud, right? Make a note of this. It's not a part of this is not a part of the answer. This is a part of understanding the answer. You don't have to write this. It's not a part of, you don't have to show this part in your answer. But you need to understand this to understand the answer. Make a note of this, children.
Taken, ma'am.
All right. So x is equal to 0 can be treated as a linear equation in one variable x or a linear equation in two variables x and y. One variable x, point on the number line. Two variables x and y, straight line in the Cartesian plane. To get the straight line in the Cartesian plane, we need the xy table. And we need the values against x and y. When x is equal to 0, x is always 0 for any value of y. And that will satisfy the equation. We'll see that now. That will satisfy the equation. What is the equation? X plus 0y is equal to 0. And what have we taken? X is always 0 for any value of y. X is always 0 for any value of y. Let's see if it satisfies the equation. What are the LHS? X plus 0y. X plus 0y. What is x? See, let's check this. What is x? 0 plus. What is y? 0 into minus 3. Correct? See, I've used the value of x 0 and y is minus 3. 0 into minus 3. So 0 plus 0, which is 0, which is the RHS, which is the RHS. See here, the RHS is 0. Again, LHS, x plus 0y. And when x is this one, x is 0 plus 0 into y is 0. So 0 into 0 is 0. 0, you can see there, it's 0, which is the RHS, which is the RHS. And when x is 0 and y is 3. Okay. X is 0, y is 3. X is 0, y is 3. Y is 3. 0 plus 0 into 3 is 0. So 0, which is the RHS. 0 into 3 is not 3. 0 into 3 is 0. So you can see that these points satisfy the equation. These points, what we have taken here on the table, they do satisfy the equation. So we are right. We are right. So what is it? X is always 0. X is always 0 for any value of y. X is always 0 for any value of y. Now let's plot this. Let's plot this. 0, comma, minus 3. Where is it? Roughly, okay. So see here, 0, comma, minus 3 here. 0, oh, 0, comma, minus 3. Sorry. Sorry. 0, comma, minus 3. So 0 here, minus 3 here, children. Sorry. Okay, this is 0, comma, minus 3. 0, comma, minus 3. Then 0, comma, 0. 0, comma, 0. Here, children, 0, comma, 0. And then 0, comma, 3. 0, comma, 3. Somewhere here, 0, comma, 3. Now, do we need to join these 3 points? No. The points lie on the y-axis. So x is equal to 0. We know that x is equal to 0 or x plus 0y is equal to 0. Okay, let me say x plus 0y is equal to 0. It's a straight line in the Cartesian plane. And to obtain the straight line, we plotted the 3 points. And now you took your scale and you took your pencil and you wanted to connect these 3 points. But you see that they are already connected by the y-axis. The 3 points are already connected by the y-axis. You don't have to draw the line. Normally, when you plot the 3 points, you'll have to use a ruler and a pencil and join the 3 points and get the line. But what you see here, the 3 points, they're already connected by the line, which means that the 3 points lie on the y-axis itself. So x is equal to 0 is the equation of the y-axis itself. Remember that the x-axis and the y-axis are also straight lines. So even they have equations. See, like if it is a linear equation in two variables x and y, there is a straight line in the Cartesian plane. If there is a straight line in the Cartesian plane, then it should have a linear equation. It should be represented by a linear equation in x and y. Vice versa. When you have a linear equation in x and y, you know that you can represent that by a straight line in the Cartesian plane. The other way, if there is a straight line in the Cartesian plane, then it should have an equation in x and y. So in the Cartesian plane, we have the x-axis and the y-axis, which are straight lines. So even they are given by some equations. Even they are represented by some equations. So x is equal to 0, x is equal to 0, or you can say x plus 0, y is equal to 0, or simply x is equal to 0, is the equation of the y-axis itself. Y-axis is a straight line. It is given by a linear equation, and that equation is x is equal to 0. X is equal to 0 is the equation of the y-axis. Because see here, x is equal to 0 when you made the xy table, and when you plotted these points, see here, these are the 3 points. And you don't have to connect the 3 points by a line. They're already connected. By whom? By the y-axis. The 3 points lie on the y-axis. So x is equal to 0 is the equation of the y-axis. X is equal to 0 is the equation of the y-axis. That's the important result which you need to take down. X is equal to 0 is the equation of the y-axis. X is equal to 0 when treated as a linear equation, in two variables x and y, in two variables x and y, is the equation of the y-axis, which is also a straight line. That also should be represented by an equation, and the equation is x is equal to 0. You can just put this in a bracket. Oh, sorry. X is equal to 0 is the equation of the y-axis. Right on, children? You can make this, you can show this rough graph here, see here, this one. Very important. I'll give you some time.
Completed, ma'am.
All right. So x is equal to 0 is the equation of the y-axis. So now you all can guess the equation of the x-axis. What will be the equation of the x-axis? If x is equal to 0, if x is equal to 0 is the equation of the y-axis, then what will be the equation of the x-axis?
Y is equal to 0.
Y is equal to 0. If x is equal to 0 is the equation of the y-axis, then y is equal to 0 will be the equation of the x-axis. Children, please make a note. Remember, this is not a part of this answer. Question number 3.
Completed, ma'am.
Yeah.
Completed, ma'am.
All right. So now, we'll just continue to understand what is y is equal to 0, though it is not needed now. But since you now understood the equation of the y-axis. We'll understand the equation of the x-axis also. I'll clear the slide. Now, what is this y is equal to 0? Again, when you treat this as a linear equation, one variable x, one variable x, one variable y, not x, one variable y, it's a point on the number line. If you treat it as a linear equation and one variable y, it's a point on the number line. If you treat the same thing as a linear equation, two variables x and y is equal to 0. If you treat it as 0x plus y is equal to 0, as a linear equation, two variables x and y, then the table goes like this. Y is always 0. See here, y is equal to 0. So y is always 0 for any value of x. For any value of x. Y is equal to 0 when you treat it as a linear equation, one variable y, it is a point on the number line. One variable y, it's a point on the number line. Two variables x and y, that means you'll have to write it like this, 0x plus y is equal to 0. If you treat it like this, then it's a straight line in the Cartesian plane. So for that, to get the straight line, we need to make the xy table. And in the xy table, y will always be 0 because y is equal to 0. Y is always 0 for any value of x. Now let's plot this. Let's plot this. Minus 5 comma 0. So minus 5 comma 0 here. Minus 5 comma 0. 0 comma 0. This is 0 comma 0. 3 comma 0. Somewhere here. 3 comma 0. So again, you see that all these 3 points lie on the x-axis. They're already connected by the x-axis. So the straight line is the x-axis itself. The straight line is the x-axis itself. You don't have to draw it. It's already connected. The 3 points are already connected because they lie on the x-axis, which means y is equal to 0 is the equation. See, x-axis is a straight line and its equation is y is equal to 0. So y is equal to 0 when treated as a linear equation, when treated as a linear equation in two variables, x and y is the equation of the x-axis, y is equal to 0 is the equation of the x-axis. That's all. Because they are also straight lines. Even they need some equation. So x-axis is y is equal to 0. Y-axis, x is equal to 0. And how will you make the table? Y is always 0 for any value of x, or x is always 0 for any value of y, depending. If it is x is equal to 0, x is always 0. Y is equal to 0, y is always 0. Write down this, children. So now, okay, finish it until. Let me know, children, once done.
Completed now.
Yeah. I'll let you. Good. Now going back to question number 3. Yeah, good. So going back to question number 3. So we have a straight line for this equation. We have a straight line for this equation. Now this is also, so now see here, now shade the region bounded by these two lines with the line x is equal to 0. With the line. So you will wonder, x is equal to 0 has only one variable x, then it's a point on the number line. No, but see here, the words used with the line x is equal to 0. That means they're treating this as a linear equation in two variables x and y. With the line x is equal to 0, they're saying. That means they're treating it as a linear equation in two variables x and y. So in that case, x is equal to 0 is the equation of the y-axis. So the third line is the y-axis itself. X is equal to 0 is the equation of the y-axis. So x is equal to 0 is the y-axis itself, which is the third line. Y-axis itself is the third line. How do we know that? Because it's given with the line x is equal to 0. X is equal to 0 is the equation of the y-axis. So the third line is the y-axis itself. The third line is the y-axis itself. These are the two lines. See, we have a straight line for this on the graph paper, another straight line for this, and the third line is the y-axis because with the line x is equal to 0, which is the y-axis itself. So the question is, shade the region bounded by these two lines, that is this line and this line, with the y-axis. So see here, watch carefully. Now, this triangle is the region bounded by the two lines and the x-axis. See here. Now, when we say triangle, it has three sides. So one side, now we have three lines, right? We have three lines. We have 1, 2, 3 lines. So one side of the triangle must be from this line. Or say the first side of the triangle must be from this line, second side from this line, and the third side from this line. The three sides of the triangle should be formed by these three lines. The three sides of the triangle must be formed from these three lines. So that means there should be one side of the triangle from this line, another side of the triangle from this line, and another side of the triangle from this line. So see here. This is one line, okay? This is one line. This is one line. And this is that one side of the triangle from this line. This is the other line. This is the other line. This is the other line. And this is the second side of the triangle from that line. And the y-axis is the third line. Y-axis is the third line. And this is the third side of the triangle from the y-axis. So this is the region which you should shade. See here. This side is from one line. This side is from the second line. And this side is from the y-axis. That is the triangle which is bounded by the three lines. Watch that carefully. See, when you take, this is one side of the triangle. That is from one line. This line. From this line, you get one side of the triangle. From this line, you get the second side of the triangle here. And from the y-axis, you get the third side of the triangle here. That is the region bounded by the two lines, enclosed by the two lines and the y-axis. This is the region enclosed by the two lines and the y-axis. So see here, the two lines and the y-axis, See, this is the triangle. This is one line. This is one line. Can you see the triangle made by the blue line, red line, and the black line? That's a triangle. That is a triangle. This one. This is the triangle. Can you see one side here? The red side, blue side here, red side here, and the black side here. Now, supposing you have to shade the triangle enclosed by the two lines and the x-axis, that is y is equal to 0. Supposing we have to shade the triangle enclosed by the two lines and y is equal to 0. That means the x-axis with the line y is equal to 0. That means the x-axis. That means the x-axis. Y is equal to 0, meaning the x-axis. So see here with the x-axis, this is one line. Okay. The second line here, this is the second line. And the x-axis and the x-axis. This is the x-axis. Y is equal to 0 is the x-axis. This is the x-axis. So you can see here, this is the triangle. This is the triangle. This is the triangle bounded by the two lines and the x-axis. Bounded meaning enclosed. Enclosed by the two lines and the x-axis. That is y is equal to 0. So the question can be shade the triangle, shade the region bounded by the two lines with x is equal to 0 or y is equal to 0. X is equal to 0 is the y-axis. Y is equal to 0 is the x-axis. Then write out the coordinates of the vertices of the triangle. So this one, these are the three vertices of the triangle. These are the three vertices of the triangle. These are the three vertices of the triangle. Here, this one, and this one. These are the three vertices of the triangle. So write their address, write their coordinates 1, 1, and this one is 0, this one. Please read it clearly. You from your graph paper. So I've written it out. I have written it out here. 1, 1, 0.175. Maybe it's between 7 and 8. And 0.0, minus 0.5. Can check it. See, 7.5 meaning maybe the line is between the 7th division and the 8th division. Between the 7th division and the 8th division. So here, this one. You can write 1.7, 1.8. Maybe here for me, the line went between the 7th and the 8th line. So I've written 1.75. You don't, even if you write 1.6, sometimes your teacher will be okay with it and give you marks. That's fine. 1.6, 1.7, 1.7, 1.8 will be accurate. Yes. Any questions? Any doubts, children?
No, ma'am.
No, ma'am. The next question, for what value of P x is equal to 2, y is equal to 3 is a solution of p plus 1 of x minus 2p plus 3 of y minus y is equal to 0, and write the equation. I'll show you the answer. Please understand yourself. Work this. It's given x is equal to 2, y is equal to 3 is a solution. That means it will satisfy the equation. So in place of x, use 2. In place of y, use 3. You will understand. Please work it.
Completed, ma'am. Completed, ma'am.
Yeah, done?
Completed.
Yeah. So what is it here? Because it's given that x is equal to 2 and y is equal to 3 is a solution of this equation. It's given that these values are solutions, not solutions. This ordered pair 2, 3, 2, 3, x is 2, y is 3. So this ordered pair 2, 3 is a solution of this equation. That means it will satisfy the equation. It will satisfy the equation. So in place of x, use 2. In place of y, use 3. Solve and find the value of p. So p is minus 2. Now the question, so what is the value of p? P is minus 2. And what's the question? Write the equation. Now that you got the value of p as minus 2, write the equation. So what is the equation? The equation will be p is minus 2. So it will be minus 2 plus 1 of x minus p is minus 2. Okay, this is minus 2. So this will be minus 2 plus 1, minus 3. Sorry, minus 2 plus 1 is minus 1 or minus x. See here, minus x. And here 2 into minus 2, minus 4. Minus 4 plus 3, minus 1. Minus 1 into minus outside here is plus. Plus 1 or plus y. Plus 1y or y. Minus 1 is equal to 0. Minus 1 is equal to 0. Or you can change the signs throughout. You can change the signs throughout. Minus x as plus x, plus y as minus y, minus 1 as plus 1, and 0, you should change the signs throughout. Sanjay, you should change the signs throughout. Sanjay and Sindhu, are you following?
Yes, ma'am.
Is it boring?
No, ma'am.
Okay. So you can change the signs throughout. For example, if you have x plus y is equal to 5, changing the signs throughout means minus x minus y is equal to minus 5. You must change the signs in both the left-hand side and the right-hand side. Similarly, here changing the signs throughout means minus x becomes plus x, plus y becomes minus y, minus 1 becomes plus 1 is equal to 0. So 0 does not carry any sign. So it is 0. But supposing, I'm like saying if there was a 5, then you must write minus 5. Or if it was minus 5, you should write plus 5. You must change the signs in both the LHS and the RHS. You can leave it like this, or you can also write it like this. Do we understand this part? Here you should not write the values of x and y. X and y you should use and find the value of p. After finding the value of p, use the value of p here. Use the value of p here and find the equation in x and y. Is it fine? All of you?
Yes. Yes, ma'am. Yes.
Okay. Okay. X is equal to 2, y is equal to 3 means 2 comma 3. All right. The sum of a two-digit number and the number formed by reversing the digits is 176. Frame a linear equation in x and y. Frame a linear equation in x and y. Again, this is of 8th standard. I'll show you the answer. Understand?
Completed, ma'am.
Yeah. All right. So if you call the tens digit as x and ones digit as y, so the original number will be 10 into x plus 1 into y, or 10x plus y. That's how we write a number in the expanded form. Now, for example, the number is 579, ones, tens, hundreds. So how do you write this number in the expanded form? 5 into 100, because it's in the hundreds place. 5 into 100 plus 7 into 10, 7 into 10 plus 9 into 1, 9 into 1. This is how we write the number in the expanded form. 579 is not 5 plus 7 plus 9. 5 plus 7 plus 9 will not give you 579. But this expression will give you 579. 500 plus 70 plus 9 is 579. 500 plus 70 plus 9 is 579. So similarly here, tens, ones, x, y. So 10 into x plus 1 into y. So 10x plus y is the expression for the original number. When the digits are reversed, the place values cannot be reversed. You cannot write ones here and tens here. The place values will not be reversed. The digits are reversed. Place values will remain the same. That we cannot change. The digits are reversed. That means x becomes the ones digit and y becomes the tens digit. Now the expanded form will be 10 into y plus 1 into x. 10 into y plus 1 into x. So the expression for the number, the new number will be 10y plus x. 10y plus x. So this is the expression for the original number. This is the expression for the new number. These are the digits of the number. X and y are the digits. X and y are the digits. Y and x here are the digits. This is the expression for the number. Now what is given? According to the condition in the question, the original number plus the new number is 176. The sum of a two-digit number and the new number, that is the number formed by reversing the digits, is 176. So this is the original number. This is the new number. They add up to 176. So 10x and x, 11x plus 11y is equal to 176. 11 common. X plus y is equal to 176. X plus y is equal to 176 by 11. 176 divided by 11, which is 16. X plus y is equal to 16 is the required linear equation in x and y. You can also write it in the standard form like this. X plus y minus 16 is equal to 0. You can also leave it. It'll be better you leave it like this. I'll also change the slide. It'll be better you leave it like this. X plus y minus 16 is equal to 0 in the standard form. Please write this. X plus y minus 16 is equal to 0. Is the required linear equation. Is the required linear equation. Linear equation. All right, children?
Yes, ma'am.
All right.
Yes, ma'am.
All right, children. Yeah. Write the equations of two lines passing through this point. Yeah, let's understand the question first. So theoretically, we know that when you're given a point, there are infinitely many lines. There are infinitely many lines passing through a given point. There are infinitely many lines passing through a given point. Yes or no, children? Do we know this? There are infinitely many lines. Given a point, there are infinitely many lines passing through it. So if there are infinitely many lines, those lines must be given by some equations in x and y. Because if it's a straight line, then it is given by a linear equation in x and y. So if there are infinitely many lines passing through a given point, that means you can write infinitely many linear equations in x and y. for those straight lines passing through the given point. I'll come again. The theory is, given a point, you can draw infinitely many lines passing through it. Given one point, you can draw infinitely many lines passing through it. Okay. So now say this point is -4, -7. So you can draw so many lines passing through this point for -4, -7. That is, this point is in the Cartesian plane. This point is in the Cartesian plane. So where will it lie in the Cartesian plane? -4, -7, somewhere here. -4, -7. This is -7. So somewhere here. Okay, so -4, -7. Now through this point, there are so many lines. There are so many lines passing through this point. So this line has an equation. This line has an equation. This line has an equation x and y. So there are, you can write many equations. But the question is, write the equations of two lines. There are infinitely many lines passing through this point. You can't write all the equations. Write any two. Write the equations of two lines passing through this point. The point is -4, -7. There are infinitely many lines passing through this point. You are asked to write the equations of two lines that pass through this point. So for that, what you do, see here. These are just two examples. You can use this idea and construct your own. So what you do, you find 2x. See, when I explain fully, you will understand what it is. I have found 2x. What is 2x? 2 into -4, -8. Then I found 3y. 3y. What is 3y? 3 into -7, which is -21. Now, what is 2x plus 3y? You can even do 2x minus 3y. I have done 2x plus 3y. What is 2x plus 3y? So that means -8 plus 12. See, add 2x plus 3y is equal to -8 plus -21. So 2x plus 3y is equal to -29, or 2x plus 3y plus 29 is equal to 0 is one of the many equations. Now, if you write like this, if you say 2x minus 3y, 2x minus 3y, you can write 2x minus 3y is equal to -8 minus -21. So you will get 2x minus 3y is equal to, what is -8 plus 21? What is this, children? 13 plus 13. So you will get plus 13 here. So 2x minus 3y minus 13 is equal to 0. So not that you should only add, you can even subtract. And it's not that you should take 2x only. You can take 3x, 4x, 5x, or simply x, simply y, whatever. So I have found 2x, which is -8. I have found 3y, which is -21. And then I do 2x plus 3y. So 2x plus 3y is equal to -8 plus -21. And that gives you this. You can leave it in the standard form. 2x plus 3y plus 29 is equal to 0. See the other example. I found 4x. 4x. So 4 into -4, -16. Then I've just taken y. I didn't do anything. I didn't find 2y or 3y. I just took y. Y is -7. Now I've performed 4x minus y. I've performed 4x minus y. 4x minus y. So it will be -16 minus -7. 4x minus y will be -16 minus -7. Because see, children, this is the value of 4x. This is the value of y. 4x minus y. What is -16? That's the value of 4x. What is -7? That's the value of y. 4x minus y. So you should put that minus sign in the middle. Okay, so the other equation is 4x. You can write it in the standard form. 4x minus y plus 9 is equal to 0. So these are the two equations of the infinitely many equations. Now you can form easier ones like this. Now I'm sure all of you understood this.
Yes, ma'am. Yes, ma'am.
Okay. Now we could just form some easy ones, very, very easy ones we can do. Now for that, x is equal to -4. Y is equal to -7. Simply add these two. What is x plus y? What is x plus y? -4 plus -7. So x plus y is equal to what? -11. Or x plus y plus 11 is equal to 0. See, simple, like this you can write. Not that you should work 2x, 3x and all that. Then write x is equal to -4. Write y is equal to -7. And subtract. So x minus y is equal to -4 minus -7. So x minus y is equal to -4 plus 7. X minus y is equal to 3. Or x minus y minus 3 is equal to 0. So these are also two equations. Take down everything, children. You can even cross multiply like this. Look at this, children. What is x by y? What is x by y? -4 by -7. Yes or no? Yes or no?
Yes, ma'am. Yes, ma'am.
Yeah. Now, can I cancel the minus and minus? Yes, you can. Now cross multiply. 7x is equal to 4y or 7x minus 4y is equal to 0. This is another equation. So you can write, this is the x value. X is equal to -4. Y is equal to, x is equal to -4. Y is equal to -7. You can write them one below the other, add the two equations, and get the linear equation, or subtract and get a linear equation, or you can even do this. X divided by y is equal to -4 by -7. Cross multiply and get the equation. Write everything, children. Start writing from here.
Completed, ma'am.
Very good.
Completed, ma'am.
Yeah.
Completed, ma'am.
Is it easy to understand, children?
Yes, ma'am. Yes, ma'am.
Yeah, please practice. Now that you've understood, you need to practice. You need to go through this once or twice to retain this in your memory. If you don't practice, you will forget. Yeah, this is the next one. Please write down this also.
Completed.
Yeah. Done, children?
Yes, ma'am. Yes, ma'am.
All right. Since graph making is time consuming, I just want you to do this at home so that you can do it at leisure. Otherwise, you'll have to hurry up in the class. It may not come out neat. That's why I'm giving you this as homework. So please, this is the question, children. Yeah, this is the question. Take a screenshot. Only one sum. Only one sum. Just complete this alone by the next class. Please take a screenshot. Done, children?
Yes, ma'am. Yes, ma'am.
Yeah, very good. And this is the solution. 1 minute, 1 minute. Yeah, this is the solution. You can see the graph also there. Try to understand how much ever possible. I will be explaining this in the class. But when you make the graph, don't do it blindly. Try to understand something so that when we discuss in the class, it becomes very clear to you. Taken a screenshot, children, all of you?
Yes, ma'am. Yes, ma'am.
All right, children. Fine, children. So that's it for today's session. Thank you so much. You may leave the call.
Thank you, ma'am. Thank you,
Thank you,
ma'am.
children.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.